Hi, welcome back to my channel. My name is Gina. In this video, let's talk about the matrix multiplication. Matrix multiplication is not as simple as addition and subtraction. For matrix addition and subtraction, the condition is that two matrices has to be the same size, and we simply need to add or subtract element by element. But for matrix multiplication, the condition is that the first matrix, for example matrix A, its number of column equals to the second matrix number of row. And the size of the resultant matrix would be number of row from the first matrix by the number of column from the second matrix. So suppose I would like to do A times B. This matrix has size of n by p. And the element of the resultant matrix can be calculated using this formula. The element of A times B in row I and column K is the sum of the first matrix along the row and times element-wise with the second matrix along the column. Let's look at the first example. In this example, matrix A has size of 2 by 2. And matrix B has size of 2 by 3. Then we know that A times B will have size of 2 by 3 because matrix A has 2 rows and matrix B has 3 columns. So matrix A times B is matrix 0, 1, 2, 3 times matrix B 1, 2, 3, 4, 5, and 6. We know that the resultant matrix is 2 by 3, so we should have 6 elements. To calculate the element, we are going to use the equation above. So the first element would be A times B, first row and first column. It would be the sum from j equals to 1 to n, and n is number of column of the first matrix, which is 2. And it's the sum of the first matrix along the first row, and the column is j, and times the second matrix along the first column, and row is j. Then we expand the summation. A's first row is 0 and 1, and B's first column is 1 and 4. So if we expand the summation, when j equals to 1, that would be the element of A in the first row and first column times the element of B in the first row and first column. Then plus the second term will be when j equals to 2. So it will be the element of A in the first row, second column, times element of B in the second row and the first column, which is 0 times 1 plus 1 times 4, which equals to 4. So this is the first element of the resultant matrix. Then we can do the same thing with the other 5 elements. For the second element, let's look at the first row and second column. It will be the sum of elements of A along the first row times element of B along the second column. And here is still from j equals to 1 to 2. So now we want to multiply element by element from the first row of the first matrix times the second column of the second matrix. So this is element of A in the first row and first column times element of B in the first row and second column plus element of A in the first row and second column times element of B in the second row and second column, which is 0 times 2 plus 1 times 5, which equals to 5. So this is the element of A times B in the first row and second column. Then for the third element, we want to multiply element by element from the first row of the first matrix with the third column of the second matrix, which is 0 times 3 plus 1 times 6. So this is 6. Then moving on to the second column, the first element is the sum of the product along the second row of the first matrix with the first column of the second matrix, which is 2 times 1 plus 3 times 4. So 2 plus 12 is 14. Then the second element in the second row would be the sum of elements along the second row of matrix A times the elements in the second column of matrix B, which is 2 times 2 plus 3 times 5. So 4 plus 15, that is 19. And the last element will be the second row of matrix A times the third column of matrix B. So 2 times 3 plus 3 times 6, that is 6 plus 18, which is 24. Now let's look at one more example. Here I have two matrices, C and D. Let's first find out whether we can do C times D or D times C. So matrix C has size of 2 by 2 and D has size of 2 by 3. But the condition to do matrix multiplication is that the first matrix number of column equals to number of row of the second matrix. So here the only possibility is to do C times D, since C has 2 columns and D has 2 rows. So the resultant matrix will have size of 2 by 3. So C times D is 2 by 2 matrix 1, 0, 2, 1 times a 2 by 3 matrix negative 1, 0, 3, 2, 1, and 1. And the resultant matrix is a 2 by 3. So we'll have 6 elements. The first element will be the sum of this row times this column. So 1 times negative 1 plus 0 times 2. That is negative 1. And the second element would be the first row times the second column. So 1 times 0 plus 0 times 1. That is 0. And the third element would be the first row times the third column. So 1 times 3 plus 0 times 1. That is 3. Moving on to the second row, we will sum up the elements of the second row from matrix C times the elements from matrix D along the first column. So 2 times negative 1 plus 1 times 2. That is negative 2 plus 2 equals to 0. Then the second element in the second row will be the second row times second column. So 2 times 0 plus 1 times 1. That is 1. And the last element, second row times the third column. So 2 times 3 plus 1 times 1. That is 7. So this will be the resultant matrix of C times D. Note that the order of multiplication is important for matrix multiplication because we want to match the number of columns from the first matrix with the number of rows from the second matrix. So if we can do A times B, that doesn't necessarily mean that we can do B times A. Even if we can do B times A, it doesn't mean that the result of A times B equals to B times A. Here there are two other properties. First one is the associative property. Suppose we have a product of 3 matrices. I can calculate the product of the later two, so I calculate B times C, then A times the resultant matrix of B times C. And this equals to, if I calculate the product of the first 2 matrices, A times B, then use the resultant matrix to times the third matrix, C. The second property is the distributive property. Suppose I have matrix A times sum of 2 matrices, B plus C. I can distribute matrix A to B and C. So this equals to A times B plus A times C. The other way around also works. A plus B times C, I can distribute the matrix C to A and B. So this equals to A times C plus B times C. That is the end of the video. If you have any questions, feel free to comment below. If you like my videos, please like and subscribe, and I'll see you in the next video.